Here we are, the dreaded hyperbolic paraboloid. Alright, the hyperbolic paraboloid is one I think most students tend to have a hard time drawing. So to draw this, let's first talk about the traces. Okay, so the first thing I'm going to do, I'm going to talk about the xy plane. So the xy plane. So if I let z be 0, okay, if we let z be 0, we're going to get 0 equals y squared over 4 minus x squared. So we would get the line x equals plus or minus, what's that, y over 2. We would get lines here. Now that's a little bit tricky to deal with, okay? A lot of times people they're tricky to deal with. But if we want to think in terms of hyperbolas, remember these are going to be the asymptotes on the xy plane. They're going to on the xy plane we're going to have these little asymptotes right here. Next, let's take a look at the xz plane. In the xz plane, y is 0. And if we do that, we would get z equals negative x squared. And this is a parabola right there. And even if we look at the yz plane, where we let x be 0, we're going to get, letting x be 0, we would get z equals y squared over 4, which is a parabola. Now, there we go. These are what I'm going to use to graph this. These are what we're going to use to graph. Okay, so when I graph this, x, y, z, and it does go down like this as well. When we graph this, I'm going to start with the positive one. What this is telling me on anything on the yz plane, we have a parabola. That's what this tells me. Parabola. So on the yz plane, I'm going to draw a parabola going up on both sides. I'm starting with this one first. And then second, I'm going to move to z equals negative x squared. Well, if this is a parabola on the yz plane, this is a parabola on the zx plane, going down. Next, what I know from here now is if I just stare at this, this is basically saying anything parallel to the xz plane will be a parabola. So what this kind of telling me is that if you think of the parabola we drew on the yz plane as kind of like a string tied between two trees, and we're going to drape a cloth over it. And what's going to happen, we get a shape that's kind of like this. And on the other side, we might have a little bit right there. And we can kind of connect it, like so. And there's our hyperbolic paraboloid. Now, you might be thinking, well, we got the parabolas, we get that. What about the hyperbolas? Well, you got to remember, this is kind of coming out like this. From here, this shape is bending. It kind of bends out along anything parallel to the yx plane. That's what this is kind of saying right here. Anything parallel to the yx is a hyperbola, and that's what these lines tell me, right? They're basically the asymptotes of a hyperbola. So let's take a look at another one that we can kind of draw. Let's take a look at another example. Let's say this time we go x equals z squared minus y squared. So a quick way to look at it, a quick way to graph, the first two is where you start. So on the xz plane, I'm going to draw my parabola. I know it's going to be a parabola because if I let y be 0. So on the xz plane, I'm going to draw my parabola. Z, and there's x. I'm going to draw my parabola right there. And then I'm going to look at the xy plane. On the xy plane, I'm going to draw upside down parabolas. I know it's going to be an upside down parabola because z is 0, I get negative. I draw upside down parabolas. So there's y, keeps going this way, and I'm going to draw basically parabolas going down. Like so. And just like that to get into my 3D. And there's our shape. This is called a hyperbolic paraboloid or a saddle. So I hope you guys enjoyed it. Smash that like button if you did. If you didn't, smash it anyways. Bye.